Okay guys, so in this video we're going to be looking at integration rules. Now the integration rules are all there on the left hand side of the screen. We should know all of those. Just a couple extra ones, extra things to remember. If you have f of x given to you, then the capital F of x denotes the antiderivative. That's really important. If you're given f dash of x equals, then f of x is the antiderivative, yes, but if you're given f of x, you need to use capital F as your antiderivative. A couple of things over here. If you have a constant multiplying a function, you can bring it at the front and multiply the antiderivative of the function by the constant. So if I had something like 2, I don't know, sine of x dx, I can just make it 2 sine x dx like that in the integral. But that only works if it's a constant multiplying. We do not pull out variables to multiply. If you've got variables multiplying, it's either one that you're going to expand brackets first and do things individually, or we can't do it without using integration by recognition in 12 methods. In this one here, we can split this up. The most common mistake for this one is to write f of x dx plus c. But you've got to remember that c is also being anti-differentiated. So what you end up doing is anti-differentiate the c. C is a constant. That would become cx. Just like if it was 2, it would become 2x. You know, that was cx in there. So just a couple of rules of how to split integrals if needed that you need to remember. So let's go through and use these rules here to do some anti-differentiation. So first one, nice straightforward one to start with, is 3x squared. So the antiderivative of 3x squared, we can write it like this. Now, according to our rule at the top here, we know we increase our power by 1 and we divide by that new power. So we have 3x squared now becomes 3x cubed over 3, which cancels out and gives you x cubed. Now, something I haven't written there yet, I'm going to now, that you need to remember every time is to write plus c. And this is our constant of integration or anti-differentiation constant. And that's important to include, because if you are anti-differentiating something, you don't know what's happened with the constant, because all the constants you get in an antiderivative, sorry, in a derivative, disappear. So if I had y equals x plus 2 and differentiate that, you get dy dx is 1, and the derivative of this is missing. And I could have a whole bunch of, 0, sorry, I have a whole bunch of different equations. If I differentiate all of those, they all just equal 1, because they all disappear in the derivative. So when you anti-differentiate something, there's no way to know what number was at the end there unless you're given further information called initial conditions. So unless I'm given an original point, an x equals or a y equals, I need to stop with x cubed plus c. Same thing here. I'm going to do the antiderivative of sine of 4x dx. Now, according to the rule that I have up here, here's our rule. The antiderivative of sine is negative 1 over k of cosine kx. Now, these rules all work if there's a linear inside there. If it's non-linear inside there, either you need integration by recognition or a calculator in our methods course. So this becomes negative 1 over the 4 that is there. Cosine 4x. And once again, we have our plus c, the constant of integration there. If I knew an x and y value, I can find it. We'll do an example towards the end of that. Okay, so if I have the antiderivative of this one, once again, we're going to write it out properly. 2 cosine 3x dx. The antiderivative of cosine, according to our rule up here, is positive sine. Don't get that mixed up with your differentiation rules. That's going to give you 2 times by 1 over 3 sine of 3x plus c, which is going to give you 2/3 sine of 3x plus c. Two more examples. 3 over 2x plus 1 dx. Now this one, before you go any further, you should write this as 3 bracket 2x plus 1 to the minus 1 dx like this. And you recognise, hang on, there's a negative 1. There's an issue there. If I go to my rule up here, this rule here only applies if n is not negative 1. Because if n is negative 1, you're dividing by 0, it doesn't work. Instead, you need to come down here and use our logarithm 1. So we're going to have the factor of x comes out the front and divide it. So we end up with 3 times by, we have log of 2x plus 1 like that, and we have 1 over 2, because we have this constant of x, coefficient of x comes out the front as 1 over a, and that is what it says there. And then we simplify that, or plus c at the end, we simplify that with 3 over 2, and we end up with that. 2 more examples. With this last one, I'll chuck in an added thing of when x equals 2, y equals 3. And we will work that out in a second. For this one, once more, antiderivative, trying to show all the different rules here. With a plus, you anti-differentiate each part. So our e to the 4x, we've got 6 times by, the rule tells me, 1 over the constant, or the coefficient of x, which is 4, e to the 4x, plus the antiderivative of x squared, what's x to the power of, you raise the power by 1, divide it by that power, plus c, and you end up with, simplifying this, you get something that looks like this. You can't leave it as over 2 over 3 here if you wanted, or you can leave it at 1/3 at the front. Final one, this is that rule where you increase the whole powers of the brackets by 1. That's this top rule up here, this second rule here. So anytime the bracket like that, as long as n is not negative 1, we increase the power by 1, divide by that new power, and we also divide by this coefficient of x, because in the derivative that would have come out the front and multiplied. So we've got to divide by this 3 and divide by this 7. Now it says times in the denominator, but if I multiply in the denominator, you end up dividing the overall thing by 7 plus c, and that gives you 1 over 21, 3x, take 5 to the power of 7 plus c. Now in this particular case, we can put a y equals, it wasn't defined, but I have given you x equals 2 and 3. So what we're going to do now is substitute 3 in there. In here, we're going to substitute our 2. We're substituting our initial conditions in this case. And we're now simplifying. So 3 times 2 is 6, minus 5 is 1. 1 to the power of 7 is 1. So it's 1 over 21 plus c. Therefore, c is 3 minus 1 on 21, which we can simplify. So it's 63 over 21 to get 62 over 21. Therefore, our equation is y equals 1 over 21, 3x take 5 to the power of 7, plus 62 over 21. And that is how you apply anti-differentiation rules and find the value of c.